In lesson 5, we used the analogWrite function to read the value of a potentiometer that was connected to pin AO on our Arduino. And this time we're going to use a light dependent resistor and read the value of that into the same pin. So what we have here, we have our light dependent resistor, which has two legs, and on one of the legs we have it connected to another small resistor which is connected to ground, and the junction of those two legs there, with one leg of the LDR and one leg of the resistor, is connected to the analog 0 pin. The other side of the LDR is connected to the 5 volts on our Arduino. So what we have here is actually a voltage divider. So voltage will be divided between the LDR and this small resistor here, which will give us a difference of voltage going into our analog 0 pin. So remember that the analog pins on the Arduino can only read voltage. They can't read, in this case, light, or if we were using a temperature sensor or something, they can only read voltage. So here we need to use this voltage divider to give us a difference of voltage going into this pin here. So if we look at how this works on our Arduino, we load up the sketch.
Okay, so here we have our photoresistor sketch, which has an LDR, light dependent resistor, attached to the analog 0 pin on our Arduino. And you can see this is a very simple sketch. In our setup function here, all we have is the commencement of our serial communication, and we're using a baud rate of 9600. And in our loop function here, all we're doing here is just creating a variable and storing the analog read into that. So we're using the analog read function. So whatever value is on the analog read function, we're storing in this variable here, sensor value, and then all we're doing is printing that sensor value to our serial monitor. So let's load this up and see how this looks. Okay, so now if we start the serial communication, we can see that we're getting some readings there. And then if we shine a light onto that light dependent resistor, we can see that the values there change in response to the light being shone on that LDR.
So here we have the same setup, but this time I have an LED that is connected to pin 13 on the Arduino. And when the light level drops down low enough on this light dependent resistor, it will switch this LED on. So just like that.
So here we have our same setup, but this time we've put in the LED. We're attaching an LED on pin 13 here. And what we're doing here is that in the loop section here, we are, instead of just printing out the value here, we also have an if statement. So the if statement is reading that sensor value against a number that we've got in here. So if that sensor value is smaller than 100, then we're using a digital write function to set that LED to high. So what that's doing is once that light falls to a certain level, the LED will be switched on, and if the light reading is higher than this value of 100 here, then the LED will be switched off. It'll be set to low.
In this circuit here, I'm using a TMP36 temperature sensor, which is connected to the 5 volts on one side, ground on the other, and the middle pin to the analog 0 port. This is connected up to one of our previous circuits with our DC motor and our NPN transistor as a switch, so that when the temperature sensor reaches a certain point, the DC motor goes on, and when the temperature drops back down again, it switches off. So here we have the same setup, but this time I have an LED that is connected to pin 13 on the Arduino. And when the light level drops down low enough on this light dependent resistor, it will switch this LED on. So just like that. So this can be quite useful, setting up sensors in this way. And another example, in this circuit here, I'm using a TMP36 temperature sensor, which is connected to the 5 volts on one side, ground on the other, and the middle pin to the analog 0 port. This is connected up to one of our previous circuits with our DC motor and our NPN transistor as a switch, so that when the temperature sensor reaches a certain point, the DC motor goes on, and when the temperature drops back down again, it switches off.